Another topic that's going to help you as you go into your science classes is being familiar with what is called scientific notation. Scientific notation is a way to write very large numbers. And by a very large number, I mean like the distance from the sun to its nearest star, a very large distance. Or scientific notation can also be used to write very small numbers. And by a very small number, I mean the diameter of a hydrogen atom. Very, very small. And scientific notation always looks like some number times 10 written to some exponent. Now, a couple key notes about a and b, those numbers in front and the exponents. A is between 1 and 10. It can actually be equal to 1, but it cannot be equal to 10. Basically, it's a single digit with a decimal. Some examples might be like 8.46 or 2.1. Scientific notation, that first number is a single digit followed by a decimal point. The second part of scientific notation is the b, and b moves the decimal point. It tells us how many times to move the decimal point. If b is 5, we move the decimal 5 times. If b is -3, we move the decimal point 3 times. In fact, it's positive or negative also tells us something. If b is negative, it means we are working with a small number. It might be a number like 0.00000042. Really, really small number. That's going to result in a negative b exponent. If the exponent is positive, that means we're dealing with a big number. For example, it might be 8,230,000,000. That's going to result in a positive exponent because we want to have a big number. So with that in mind about what those mean and whether we're dealing with big or small numbers, we should be able to convert a scientific notation problem into a standard notation number. Let's take the scientific notation number 4.21 times 10 to the 5th. Because that exponent is a positive 5, I know I'm dealing with a big number. So when I move the decimal point, I need to move it in such a way that the number gets bigger. Moving to the right, 1, 2, and then we've got 3, 4, 5 gives us 3 extra spots that we'll fill with 0. So we have 4, 2, 1 with 3 extra zeros that got filled in. We've got the number 421,000. What if I had the number 6.2 times 10 to the -3? Well, now that exponent is negative. That tells me I'm dealing with a small number. So when I move that decimal point 3 times, I need to make the number smaller. To make the number smaller, we'll move to the left, 1, 2, 3, which means we need 2 zeros as placeholders after the decimal point before the 62. 0.0062 is our equivalent number in standard notation. Our next video will take a look at how we can go the other direction, take a standard number and change it into scientific notation.